All right, good morning, pre-calculus students. It's Saturday morning for me, October 7th, and I'm playing around with my new video recorder. And I'm going to look a little closer at what the absolute value of x function looks like and some of the things we can do with it. So I'm hoping this visual will give us a deeper understanding of the absolute value function. Now, you notice the first thing that I did was I took the absolute value function and I made it into a piecewise function where this side right here, when x is greater than or equal to 0, is the line y equals x. And the other side, the side where it's less than 0 to the left, is the line y equals negative x. Now, I hope that that's clear why that's true. Some other interesting properties of looking at this is just to add. No, I don't. I hate when that comes up. What do you, I'm doing this, I'm thinking about Damien. Damien's really concerned that we're not doing stuff like trig, and so I was thinking, here's a good question for Damien and the rest of us. What is the measure of this angle right here? And it looks symmetric, and I would think that it's also the same measure right there. Would you guys happen to guess that it's 45 degrees? Does that seem to make reasonable sense that bounded by the x-axis and the line y equals x and bounded by the x-axis over here and the line equals negative x, that's 45 degrees? That seems true. But that's just eyeballing it. How could we test to make sure that that's absolutely what it is? So let's think about a couple of ways of looking about how that could happen or why that is. Well, if you were to drop a perpendicular anywhere on that line, that of course would be a right angle right there. I notice a couple of things, that the distance from 0, 0 to 5 is, of course, 5. Going up is also 5. And, oh, check that out. I have a right triangle that's isosceles, and each of the legs is 5 units. And what do I know about isosceles right triangle? Well, Mr. Kruger and Mr. Lilly taught you guys some stuff about isosceles right triangles. They taught you that the ratio of the sides are 1 to 1 to root 2. Yeah. If I use the Pythagorean theorem, notice that 5 squared plus 5 squared would be 25 plus 25, which would be root 50. It's 25 plus 25 is equal to c squared. Root 50 is equal to c squared. So c is equal to the root of 50, and that of course breaks up to 25 root 2 is equal to c, and that would be 5 root 2. So we can see that the ratio of the sides is indeed 5 root 2, or 1 to 1 to root 2. What do you guys know about isosceles right triangles? You know that they are 45, 45, 45, 90. So indeed that's 45, and that's 45. And also another thing that's kind of cool looking at here is that if that's 45 and that's 45, but that right there happens to be a right angle, right? Because the sum of the measures of the triangles 1, 2, 3 must add up to 180. That's 180 take away 90, so that must be 90 there. But there's another way of also looking at it. Something else that we've talked about in class is that Notice what the slope is here on this guy. That happens to be a slope of 1. What's the slope on this one? That happens to be a slope of -1. And we've talked about this in class. How do I know two lines are perpendicular? Well, that means that the product of their slopes is equal to -1. And indeed, if that slope is 1 and that one right there is -1, then it's -1. So we know that those two lines right there are also they're perpendicular. So that indeed is 90 degrees right there. Okay, so got all that going. And get rid of that, get rid of that. There's my line, y equals x, and so forth. Okay, so that's a little just adding on to little things that we notice right there about the absolute value sign from a visual point of view. Now, what if I said there's this function called g of x, and that this function g of x is equal to 6? Okay, what does that mean? Well, that's a horizontal line, and it is going that way. There's g of x. And of course the next natural question is, for which values of f of x does it equal g of x? Well, you can see on the graph right here that it's going to intersect right there at 6, 6, and over on in the quadrant number 2 it's going to intersect at -6, 6. Okay, groovy. Well, let's show that algebraically. Insert space. I was going to be able to do that. Well, okay, I guess I can't. I'll go back to draw, and I'm going to erase this thing right here. You guys got all that? Okay, so I kind of wanted to have that there. So g of x is equal to f of x. Okay, so when does that happen? When does the absolute value of the function equal 6, g of x? Okay, so back to that definition, there are two cases on it. When x is greater than 0, or the positive side is equal to 6 is one case, or when the opposite of x is equal to 6. So x equals 6 is one solution. X is equal to -6 is another solution. And we can see those values right here for that one. And excuse me, that was the wrong 6 to circle. We can see the values right here, and we can see the values right here. Okay, so there's a visual of when does the geometric interpretation of solving absolute value signs.